Okay, everybody. My name is Daniel, and I'm going to run us through the 2D wind tunnel simulation for EAS 3101. Here's our wind tunnel specifications with our settling chamber, contract chamber, and test session diffuser. And bring this over. Okay, so first we open up our ANSYS workbench and make sure that you right-click here and you have your properties open. Go ahead and drag fluid flow fluent into the project schematic. From there, we want to click on geometry and change our analysis type to 2D. And then right-click geometry, and we are going to start a new design modeler geometry. And that does take a moment to load up. Oh, perfect, not too bad. Okay. First things first, we want to change our units from meters to inches. And then we are going to go over to our sketching. That'll bring up our planes. So you want to click on your Z-axis here. That will bring the planes with the XY facing us in the right orientation. From there, we're going to create a line under the draw. Click on line, and you want to line it up with the Y-axis, and you'll see Y. Click anywhere and create a line nice and vertical along the Y-axis. It's a little hard to see, but it does highlight there. From there, we are going to go to our constraints, and we are going to hit coincident. Oh, I'm sorry, not coincident. We are going to do midpoint, and it's going to ask you down here, midpoint selection point or line from constraint. We click on there, highlight our line. It's yellow. And then it's going to ask for the midpoint constraint, which we want to click on the origin here, and that little box with the point on it tells you that you're clicking a point. Boom, and that should constrain your line, so it's always the center point of the line will be right at the origin. Okay, from there we're going to select our dimensions. It should be on general. We're going to click on that line there, bring that out. And then down here in the bottom left, we can change that value. The height here was 22 inches. From here, we zoom out a little bit. As you can see, it's a little bit bigger. And let's pan that over. Okay. So from here, we are going to create the bottom portion of our 2D wind tunnel. Let's go ahead and go back to sketching. Go to draw, line, and then click on our bottom point here. And as long as that says H, I believe that that should always draw a horizontal line. So we're just going to draw the general shape of what we're looking for. Something close that we can work with later. And that's roughly what we're looking at. Okay. So what we want to do now is we want to go to our dimensions, and we want to start identifying all these dimensions. Okay, so this is going to be the settling chamber. That's going to be 15 inches. And then we need to go to horizontal because it's an angled line, so we want to make sure we go from point to point. So from this point to this point, that is going to be H3. That is going to be the contraction chamber of 24 inches, and then go back to general, because we're just going to grab the test chamber. Click on that, bring it down here. We will go 12 inches there. And then same thing here, going back to horizontal. I know it's going back and forth a little bit, but click on the end of the test chamber and the end of the diffuser, sorry. And that is going to be a length of 42 inches. All right. So that is all set. Because the test chamber, since we have this center line right on the x-axis, and this is only half of the 2D wind tunnel, that means the height of the test chamber, which we are given at 6 inches, is actually only going to be 3 from here to the mid or x-axis. We want to go vertical, click on our test chamber, and then click on our x-axis, and that will come out to 3 inches. Okay. Okay, so the next thing we're going to do is we are going to set our angle here. We want to click here, click there. And that angle is going to be 177. Okay, H5, make sure H5 is still constrained. It is. Okay. Replicate that. What happens if it actually does replicate? All right, so once we open up our mesh, actually, let's go back to this. Before we do that, we want to go back to our units, set them back to meters, and go to tools, analysis tools, and distance finder. And we want to go to selection filter edges. We're going to choose our inlet, apply, and then our outlet for edge 2, apply, and that should give you 2.3622 meters. We'll save that for later, for when we actually set up our graphs. Okay, save that. All right, and over in our mesh, make sure in our workbench, that's good. Okay, so in our mesh, once we open up our mesh, we are going to right-click it, go to concepts. No, not concept. Okay. Okay, we want to click mesh and tree. Right-click it, insert, and method. And the geometry hasn't been selected, so we click that. Click on the plane, it highlights, and hit apply. And then going to change our method to triangles. And then we're going to hit generate. Okay, and then we want to click on mesh in the tree here, and then go down to element size, and we're going to change that to 0.01. Enter that, and then generate that as well. And that should change it, yep, to many smaller triangles here. All right. So now we're going to select our edges for the boundary. We want to go to our edge control here, up here. And then these are just gonna, you're gonna have to shift click. So shift click, and then shift click, and shift click. You're gonna have to let up on the shift button every time you do that. It's a little bit of a pain. I'm sure there's an easier way to do it. And then from there, you can right click and go down to create names selection, or hit the letter N on your keyboard. And we're going to change that to wind, tunnel, wall. Hit OK. Click on your inlet. We'll hit N, wind, tunnel, inlet. Hit OK. And the same over here. N, wind, tunnel, outlet. Hit OK. Right. And that completes that. We're going to save the project, and we should be done in here. So we can go ahead and exit out of that and go back to our workbench. And then we want to right click on the mesh and update that. It's taking a while. Okay, perfect. Double click on your setup. And we want to do double precision and set that up for solver process 2 and hit start. And give that a moment to load up. Takes a second. Save on memory. We remember that this number is 2.3622. So we'll go ahead and exit out of here just to save some memory. Okay, perfect. So this is loaded up. That's all right. So we have our simulator set. We just got to set it up. We're going to go and in the tree here, we're going to go to open up models and double click on energy. That'll bring up a little window here. You want to click your energy equation, hit OK. That turns your energy equation on. Head down to your viscous right below it. Double click that. Open up another menu. Dialog box here. We will be changing our model to transition, or I'm sorry, K epsilon to equation. Make sure it's on standard for the K epsilon model. And near wall treatment, we will change to enhanced wall treatment. And the enhanced wall treatment options will be pressure gradient effects and thermal effects. Go ahead, OK there. All right. Head on down to boundary conditions in the tree. Right here. We will need to select the inlet, double click that. Okay, and from here, we are going to set our velocity magnitude. And this number is going to come from applying your v-test section formula here, 0.2489 times your frequency, which in this case is 20 hertz, minus 0.3718. And then you're going to multiply the v-test section by the ratio in area, since it's it would be area of the opening. So since it is a 2D model, it would just be towards the height. So it would be 6 inches to 22, and that will bring your number to a solid, or at least what I got, 1.256236364, just to be very accurate, and hit apply. Go ahead and close that. Head on down to solution. You want to click on initialize. Double click that, hit initialize, and then down here in your console, you'll see that it has been initialized. Okay, right below that, you're going to run the calculations. Click that, and you want to set yourself up a number of iterations. It's going to be 200. Excuse me. Okay. With the number of iterations set, you can go ahead and hit calculate. And you should see it do its convergence. Beautiful. Okay. So now that that's done, we have our Let's go ahead and get our contours and graphs. So we'll head down to results, graphics, contours, double click that. Okay. And then from here, you want to click every single one of your surfaces. And we can go ahead and it's already contours of pressure, and we will drop this box down to static pressure. Oh, it's already on static pressure, sorry. Save that display. All right, and then you want to screenshot that. Same thing with dynamic pressure. Screenshot that. And total pressure. All right, and then we're going to head over to velocity. Should be already under velocity magnitude. Save that display. Save that. Okay, and we're going to close that. All right, now we're going to work on our graphs. The graphs, go under plots, go to double click XY plot. And from here, we are going to create a new surface, and it's going to be a line. We're going to name this line center line. And because we have that number of 2.3622, and it's along the x-axis, the center line is, and the y-axis was the starting point, so we know that it's 0 there, so we don't have to worry about anything else. Create and close, highlight your center line, okay, and then you're going to hit Save Plot, and this will give you an idea of what's going to happen here. Same with dynamic, Save Plot, total, Save Plot, and then same for velocity, Save Plot. Okay. To write this to file, just click on your write to file. It'll change this box to write, and from there you can choose where you would like to go ahead and save it. So that ends this tutorial on the 2D wind tunnel for EAS 3101. I hope it was informative, and thank you.